All right, all you whippersnappers, let's talk column chromatography really quickly here. By now, hopefully you understand that column chromatography is just a technique that we use to separate different substances from each other in chemistry, or in this case, biochemistry. We only cared about GFP inside of our cell extract, but we had to literally separate all the different components that we extracted from the cell, all the salts, all the cytoplasm, all the proteins, all of that was in that green glowing thing that we had, and we just wanted the one green glowing protein, GFP, to be isolated from everything else. So we had to put it into this column, and there are two parts to the column. One was a stationary phase, which we loaded it up with this slurry kind of stuff. We'll talk about that in a moment. The other part was the mobile phase. That was the elution buffer that you kept putting liquid on top of all that slurry to drive this liquid through the column that was packed as much as possible with all the slurry. This mobile phase allows the process to take place because it's going to allow the chemical to be carried through that mixture that you put in. So the stationary phase is a solid material. It was kind of half solid, half liquid that was packed into the column. The more that you got that slurry to settle down into it, the tighter it was packed together. Now, this could be a silica gel, which is what we used, or alumina, or some other material with some specific property that's going to interact with the chemicals of our choice. Say we were interested in this picture in collecting as much of the orange little tiny beads instead of these blue beads. Well, we need to make sure that the white beads inside the stationary phase will partially bond and interact with the orange ones and not with the blue ones, allowing the blue ones to phase through at a faster pace and the orange ones to go through at a slower pace. And this all depends on what compound is being separated. We'll talk about different factors in choosing these compounds in a moment. Meanwhile, the mobile phase is a liquid or gas that flows through the column to carry the sample, and it will interact differently with the compounds both in the sample and the stationary phase. It shouldn't really interact with the stationary phase at all. It should pass through it very easily. So some common mobile phases are things that don't react very much, like organic solvents, like we're thinking of ethanol, for example. In our case, I don't actually know what our mobile phase was. It's just called buffer because it didn't really have to do anything but buffer the interaction between the mobile phase and the substances we were trying to allow to pass through. Now, the process that we actually did wasn't really diluting a solution. It was more of a process called elution, where we are passing the mobile phase through the column. Because we were passing the mobile phase through the column, the compounds were separated as they interact differently within the stationary phase. If you have a strong interaction with the stationary phase, that molecule is going to want to stay put and stay attached to the stationary phase as long as possible, which means that the mobile phase can elute it less. It's less likely to actually allow that mobile phase to pass it through, which is why we continue to add more and more column elution buffer to the top of it, not only to make sure that we had some liquid falling through, but because if we stopped doing that, eventually our GFP would be stuck in the middle of the interaction with the stationary phase, and it wouldn't be able to be pulled through into the fractions that we collected. Now, there are a couple of different separation factors that we can use to choose molecules that would go in our stationary phase and how we can get these different molecules in our substance to separate. One really common way is by charge or polarity. You know that molecules may or may not be really interacted with positive charges or negative charges, or maybe polar molecules like water or nonpolar molecules like fats and stuff. If I were to choose a polar stationary phase, then the polar molecules that are inside the substance that I'm trying to separate would stick around and try to hang on to the stationary phase as long as possible. Whereas if I had nonpolar molecules in the substance I was separating, then they would not interact with the stationary phase as much because nonpolar doesn't want to mix with polar. So in this case, we have positively charged stationary phase beads here in yellow. The uh, the positively charged proteins don't want to interact with that, so they pass through first. Meanwhile, the negatively charged proteins that are in red here went very, very slow through the stationary phase and actually had to be washed through with a salt that would prevent them from wanting to stick to the positively charged beads so that they eventually get down to the bottom. So this is one way that we can actually separate the factors, the charge of the molecule. We can also separate it by size. Most things can be separated by size. This is indeed one of them. If I have a stationary phase that has pores in it, those pores can allow small molecules to enter the pores, but the larger molecules may not be able to enter the pores. But if those small molecules get in the pores, they kind of get stuck in place. They kind of bounce around like a game of Plinko or pinball. Whereas the larger molecules, if they don't get stuck in those pores, they just kind of plow right through. So if we had this same sample with large and small molecules and those stationary beads had pores through it, then the large molecules end up through the column much, much faster. We can see at this point in time of C that there will be a lot of that one sample of large molecules. And eventually, those small molecules do get out of the pores, but it is much a longer process. So we do have these two substances that are separated from each other. These two separation factors are probably as detailed as we want to go into in this class. If you'd like to learn more about this separation of molecules and protein purification through chromatography like this anyways, let me know and I can take a look at some different programs for you available in colleges. More and more people are getting associate's degrees to work in labs doing this kind of stuff. So you could go to school for only 2 years and get some really good money out of it. Who knows? Thanks for listening. Hopefully you understand this a little bit better after this video.